All right, today we're diving into a really powerful AI technique called RAG. We're going to explore how you can take a general-purpose large language model and turn it into a super specialized expert that knows all about your private stuff, your documents.
So let's start with the basic problem. You've got this incredibly smart AI, right? But if you ask it a question about your company's latest sales report or, your personal study notes, you're just going to get a blank stare. And that's because these standard LLMs, they're trained on the public internet. They have no idea what's happening in your private, up-to-the-minute world.
So, what happens when an AI doesn't know the answer? Well, it can do something we call hallucinating, which is just a fancy way of saying it makes stuff up. It might invent facts, create fake company policies, or just give you a totally wrong response with complete confidence. And that lack of reliability, that's the biggest thing holding these tools back from being truly useful and trustworthy. To fix this, we've got to give the LLM some help. We need to build a bridge, something that connects its incredible reasoning power with our specific, factual data. And that bridge, well, that's the hero of our story today. And that hero is called Retrieval-Augmented Generation, or just RAG for short. It's a really beautiful, simple idea when you break it down into its two steps. First, the system retrieves. It goes and finds the most relevant little snippets of information from your documents. Then, it uses those facts to generate an answer. This keeps the AI's response grounded in reality, which stops it from just making things up. So how does this actually work under the hood? Let's unpack the RAG pipeline, step by step. Think of it like a kind of knowledge machine, and we're about to see how all the gears and levers fit together. Here's our map for the journey. See, it all starts with your raw documents. We'll look at how we prep them for the AI by breaking them down and turning them into a format it can search. Then, when you ask a question, the system finds the right info and uses that to generate a factual answer. So let's start at the beginning, with that crucial prep work. First things first, chunking. You can't just feed a 100-page PDF to an LLM. It has a pretty limited attention span, something we call a token limit. So we have to break our big documents down into smaller, more digestible pieces, like paragraphs or sections. We call these chunks. And I can't stress this enough. How well you do this step directly impacts the final answer. If you split a sentence in half or group ideas that don't belong together, you're going to confuse the system. The success of the whole RAG process really begins with getting these chunks right. Okay, so how do we make these text chunks searchable by an AI? We create something called embeddings. An embedding basically turns a piece of text into a string of numbers, a vector. And the best way to think about it is like a GPS for meaning. With this, a chunk about vacation policy will have GPS coordinates really close to a chunk about paid time off, even if the words are different. These vectors then get stored in a special kind of database, ready for a search. Okay, so our data is all prepped and indexed. We're ready for the action. A user comes along and asks a question. How does the system find that one perfect needle of information in our giant haystack of chunks? Well, there are a few ways to do it. You've got your traditional keyword search. That's like hitting Control Fs, looking for exact words. Then there's vector search, which uses our embeddings, our GPS for meaning, to find similar concepts. But really, the most powerful way is often a hybrid search, which combines the precision of keywords with the conceptual power of vectors. It really is the best of both worlds.
But this brings up a really subtle but super important problem. Sometimes, the chunk that is most similar in meaning isn't actually the most relevant for answering a specific question. It might be on the right topic, but it doesn't actually have the answer.
For example, let's say you ask, how many vacation days do I get? The first search might pull up a chunk talking all about the history of the company's vacation policy. It's similar, it's about vacation, but it doesn't actually answer your question. And this is where another clever step called re-ranking comes in. After that first search brings back a few possible chunks, a smarter model takes a second look. It's like a quality control expert, re-evaluating those top results to find the one that truly answers the user's specific question. The re-ranker then promotes the real answer right to the top. It finds that specific sentence that says employees get 20 vacation days per year. This makes sure the info we send to the AI isn't just vaguely related, but actually useful for crafting the answer. And now we've got it. The most relevant, concise, and accurate chunk of information has been found. We are finally ready for the G in RAG, generation.
This quote from the source material just perfectly sums up the whole goal. The success of the entire system hinges on this one idea. You don't give the LLM the whole library. You give it the exact page and paragraph it needs to give a perfect, fact-based answer.
So, now that we get the theory,
let's talk about what it actually takes to make RAG work well in the real world, because it's not always a perfectly straight line.
See, building a really solid RAG system means you have to navigate some common hurdles. You might have poorly made chunks that break the context. Your search might just miss the right document altogether. And this one's huge. You have to build in security from the very start to make sure users only see the information they're actually allowed to see.
To make sure we're succeeding, we have to measure it. A key metric is something called groundedness. The goal is for over 90% of the information in the AI's final answer to be directly traceable back to the documents we gave it. That's how we prove the system is being factual and is trustworthy.
Finally, it is so important to know when to use RAG versus this other popular technique called fine-tuning. The analogy is pretty simple. RAG is like giving the AI an open book exam. It provides knowledge right at the moment it's needed. Fine-tuning, on the other hand, is more like sending the AI to school for intense study to teach it a new skill or style, like how to speak in your company's brand voice. They really do solve different problems.
So, what's the big takeaway from all this? Retrieval-Augmented Generation, it's not just some technical process, it is the key. It's the key to unlocking the value of all your organization's data, turning a general AI into a reliable partner that understands your specific world. And that leaves us with one final thought to chew on. Just imagine, every manual, every report, every note you've ever taken is instantly accessible and understandable just through a simple conversation. What becomes possible when any document can give you a perfect, instant answer?